All right. I think that should be working now. All right. Okay, so let me redo that intro. So yeah, I haven't done one of these in a while. It's because I've been like a few weeks ago. If you're in the Discord, you might know. I got married. Then last week, I'm moving down to Miami, so we went down there to try to find a new place. That's figured out. We're in the process of moving now, so still not fully settled, but hopefully we'll be back to usual in a week or so. Um, but I wanted to share a little bit about once I'm settled, what that next phase of work is going to look like for SST. We have a lot of exciting things we're planning on doing, and it's going to be like one big chunk of work, at least on my plate. Frank and Jay are also working on separate things as well, and it's going to be leading up to probably a pretty big release in the next few months. So I wanted to share a little bit about what I'm working on. So this stream is going to be pretty casual. I just have like a few high level notes. What happened to my wall? Yeah. So if you guys look up there, those of you that watch the stream normally, you know that there's usually a bike hanging there, and there's also a litter box down there with my cats. Every time I go to scoop the litter, I like bump the bike a little bit, and every time it feels like, oh, like is this gonna fall? It finally happened yesterday, or yeah, I guess it was yesterday. Fell, left a hole in the wall. But like I said, I'm moving, so we have to have the contractor in here anyway, so that'll get taken care of. But yeah, that's why there's no bike there, then there's a hole in the wall in my set. All right. So yeah, for this stream, like I said, it's gonna be pretty casual. I have a few notes on some high level things that I want to go over in terms of what I'm gonna be working on for the new SST CLI. There's a lot it's gonna cover. I wrote down everything that I could remember in terms of like priority, but realistically, it's not gonna cover everything because it is a big project. Um, I'm just gonna go through those and share some of that. So before I get into that, I just want to lay out some of the high level goals that we have. So just to reiterate, I'm doing a new version of the CLI. The CLI that we're using today has not changed fundamentally since SST originally launched. And if you look at the structure, it's even structured as just a bunch of simple scripts. But obviously, since then, SST has matured a lot in terms of the different types of things that we handle. Before it was just like a little tool to deploy and do live debugging. Both those features themselves have gotten very complicated. We also now do a lot of other things around, like just little helper things that run during development. So if you're using your GraphQL stuff, it handles code generation for the GraphQL types. If you're using our RDS construct, it handles running migrations. It handles keeping your RDS cluster warm. There's just a bunch of things that our CLI does now, and the current architecture hasn't scaled super well for it, both in terms of performance, so how fast the CLI feel, and also just maintenance on our end. So has it been easy to add new features? Are there things that we're avoiding because they're difficult that should be simple? Enough of that has piled up now where we want to like do one concentrated effort on making all of this better. So the goals for the new CLI, I break it down into three things. And I think most of the stuff we're doing falls into these three categories. The first one, make it as fast as possible. So having used non-serverless stuff before, non-AWS stuff before, I'm pretty used to just starting my project and being ready to work. But with ever since I switched over to CloudFormation and all the AWS stuff, it's been a little bit different. There's all these moments where you kind of need to wait for something to happen, and these are like opportunities to get like distracted or to shift your focus somewhere else. We want to minimize that as much as possible. Like we want to make it feel like when you run SC start, boom, you're ready to go. There's other situations like resource updates, things like that. We want to make sure everything is as fast as possible and minimize it. So there is a ceiling on how fast we can get this stuff, mostly because one, at the end of the day, we're still using CDK, and there's some limitations on what CDK is willing to do. But we are pushing them to make certain changes on the performance side. Two is CloudFormation. Obviously, everyone knows CloudFormation is super slow, but that doesn't mean we can't be using it smarter and being more clever with how we interact with CloudFormation. So performance is a big part of this. So it's those things that I listed, but it's also just reviewing literally every single line of code and seeing what actually happens when we're calling into this. What are the underlying libraries doing? What actually makes these things slow? Right now, our CLI kind of has a lot of startup cost, um, mostly because we're like preloading a bunch of things when the CLI starts, no matter what command you're running. And we're not really loading them lazily, things like that. And in this stream, I'll go into how we're using our new context library, which was actually originally built for use in AWS Lambda. We're going to be using that same context library in our new CLI to power some lazy loading stuff, some caching stuff. It's actually scaling really well for use in the CLI, which has been interesting because it wasn't really designed for that. So anyway, summary, performance. There's like a million little things we can do. Each of those things are going to shave 100 milliseconds here and there. Once you add all of those up, it's going to feel like a much faster overall experience, even if you can't really point at what improved. The second thing is we want to make it extensible. And I think about this in two parts. So like I said earlier, as we've added more features, it's been somewhat difficult for us to add new features easily. So we need a better framework ourselves to add a bunch of features that weren't necessarily related to each other, right? When we built SST originally, we never thought there would be a GraphQL code generator in there. But we want to structure things in a way where, okay, there's a solid framework for adding new functionality. At its core, SST start is really just a process that runs and watches your files. And all the features kind of stem from that. So we want to have a good framework for that. And whatever that framework is that we're using to build new features that ship internally with SST, we want to also expose that so you can extend it with your own functionality. So even just last week, I had a situation where I wanted to run some script when a certain file changed. That's a lot to just build and annoying to build if you're just doing it on your own. Like you have to add another script that runs up. You start your project and you have to do file watching, all this stuff. SST is already watching your files. You should be able to like write a little plugin that, does whatever logic you need to in reaction to certain events that are happening. So we think that like we don't want to become a platform where SST does nothing. You have to install like 100 plugins. That's not really what this is about. It's more around SST is still going to ship with a lot of functionality built in, but there are just some things that you could do to smooth over your own developer experience. And it's nice that since SST Start is going to be running anyway, it's nice to be able to hook into some of those things. And then on the functionality side, we definitely want to be able to support. This comes up every once in a while. People want to add like their own custom runtimes for things like Rust and things we don't support natively. This extensibility approach should allow for all of that. And the third thing is make it more accurate. And this is specific to SST Start and the Live Lambda setup. So Live Lambda is pretty accurate in terms of it runs almost the exact same code that would be running when you deploy it. It runs under the exact same credentials that it would be running against when you deploy in production. But there's still a bunch of little gaps, and we've been kind of painfully aware of these for a while, but we haven't fixed it just because the cost of fixing these things in our existing CLI is fairly high. So it just never made it up to our priority list to be worth taking on that pain. But moving forward with this new effort, we want to patch a lot of those situations. So one of the things that sticks out the most is copy files. So if you use a copy files feature and if you're not aware, copy files lets you add additional files into your Lambda bundle when you ship to production. This doesn't behave super predictively locally. So that's one thing we want to fix. And I think the way we're going to fix this, we're going to have like a isolated folder where everything runs and your Lambda kind of just exists inside of that. A side effect of that is a lot of other things should also end up being fixed just by coincidence. So we want to make things more accurate. Like I said, we're already pretty good for like your basic setup, but some of you doing more advanced things, there's a few caveats when you're running the Lambdas locally. Again, there's a ceiling to this. Like we realistically can get certain things working, but there's still like a few things we want to round up. So those are the three high level goals: performance, extensibility, and accuracy. And so I'm going to jump into some of the specifics around what we're actually going to do. Is audio only in one channel for anyone else? Yeah. Okay, I know what the issue is. Give me 1 second. Let me try to fix this. I messed up my whole streaming setup recently. All right, now that should be better. Oh, did I lose a stream? And what is going on? Oh, there we go. Okay, that should be better. All right, cool. It is fixed. Let me make sure the comments up so I don't miss these. Okay, so let me pull up my notes and let's see what we got here. Okay, so with this kind of big restructuring, we are making some kind of internal changes to our own code base. So right now, the CLI is actually not written in TypeScript. I think SST was initially created in kind of like an awkward time. Like it was a time before TypeScript. I mean, TypeScript now is like almost a default at this point. It's super popular. But when SC was first created, that it wasn't as clear. The second thing is ESM now is a lot more viable than it was when SST was first started. So because of that, ST is currently not written in TypeScript to CLI. And I actually did port everything over to ESM, but it's not like fully taking advantage of certain ESM stuff. So the first thing we're doing is writing the CLI in TypeScript now. Again, that's just for our own internal benefit, but it also allows for some interesting things on the plugin side. You can write your plugins in TypeScript, and we're actually going to let you specify a configuration file as a TypeScript file, which enables a few things that I'll get into. So first thing, TypeScript. The second thing is we are likely going to make it a mono package, and I haven't fully structured this yet, but let me share my screen. So right now, let me just get a little Scratch file going. All right, so right now we have a few different packages, right? We have, you can import your resources from stack resources. And we also have, the CLI, which is separate. And we also have now like a node package. We also have like just a bunch of different packages you start to install. Like we also have SST and CLI, which is separate. So we have a lot of different packages. This is kind of a side effect of not being, this is kind of, it was made before ESM was really popular. Now that we are shipping ESM, it allows us to combine all these into a single package without really any trade-offs. I need to, again, verify this is the case, but it looks like we are going to be moving all these to a single package. So you'll be able to do something like, and we have to figure out the exact name. We're trying to acquire the SST NPM package. We haven't had a lot of luck with that yet so far. It doesn't seem to be that in use, but yeah, we're trying to figure this out. But you'll import stuff like this. So if you want stuff from the resources, you'll do SC resources. If you want to use our new config library, maybe we'll do something like this. If you want, to do programmatic, another thing we want to do is make sure the CLI can run programmatically. So you should be able to import the CLI and call it and run your own commands. So yeah, Jason, please help us. Yeah, if you guys know the person that owns the SST package, which is very unlikely, but if you know who he is, help us get in touch with him. We are very eager to figure out how to make it work so you can transfer that over to us. But yeah, we haven't had a lot of luck so far. We're also trying to get the SST like this one. So maybe we can do like, I don't know, something like that at SST. I'm really tired of typing out serverless stack. You guys probably don't type it out that much, but I type it out a lot because I'm always installing stuff and fixing things. So yeah, we're trying to figure out one of these. So yeah, we haven't figured the actual package structure yet, but at some point we will, do something like this where you're able to install a single package and import selectively. because of the way ESM works, this isn't gonna like leak additional code into like your files when you don't expect it to. Like things will still stay pretty separate without needing discrete packages. And this kind of simplifies the update functionality. So that's the monopackage stuff. So next thing I have on this list is, so using context. So I want to show a little bit. So I did start working on the new CLI code base. And if you actually look at, this is all committed. You can actually go look at this now. It's actually even being published, I think, just because, yeah, it's being published under CLI too. So if you want, you can use this. Not that it does much right now. But let me share some of how I'm using context. So we have this new CLI. Right now I'm trying out this CLI framework called Caporal. I don't know if it's gonna be the one that we end up using long term, but we've decoupled this so much that swapping out like this part of it should be pretty easy if we don't like it. All this does is like the command line flag parser and command thing. I'm sure you guys have used Commander in the past. We're using Yargs right now, but I wanted to try something new to see if it was better. So the way this works is this is entry point. We have various commands that we support, SST update. This is just a test one that I have, SST build, SST secrets, SST analyze, which we'll talk about a little bit later. And then the CLI part of it is pretty minimal, right? All we're doing is specifying what the commands look like. So let's look at SST update, for example, just what the command looks like, the arguments, nothing crazy here. And we're just calling into this update function. The reason we have it structured this way is if you want to use a CLI programmatically, you can just import this update function yourself and call it. So it should be helpful if you have scripts that you want to. It's not that common people want to run it programmatically, but there are situations where you want to, trigger a certain SST functionality from your own scripts. But this will let you do that. It's a pretty simple structure there. But in terms of how we're using context, so if you look at something like SST build, so this is like very, very simple. This isn't at all complete, but you can see we're using this like use pattern, which is kind of similar. If you're using our SST auth framework, or you've seen me talk about our context stuff, this is the pattern that we generally have, like these little use functions. So when the CLI starts, it's going to hit build and it's going to hit use config because we're going to need the config, which is the SST config. So you go to look to see how this is implemented. This is actually implemented using our SST context with the memo option. So the first time this is ever called, we're actually going to look through your file system and try to find your config file, and we're going to properly load it with the defaults and throw a nice error if we can't find it. And I'm probably getting something interesting here as well. So we're also supporting specifying your config as JavaScript or TypeScript. I haven't been on the TypeScript side yet, but you can define your config as JavaScript. This will let you do interesting things, right? You want to specify that for certain stages, you use this AWS profile, or like using some of your own logic deploy to this region. So defining the config as JavaScript lets you do any kind of logic you want without us having to provide like a ton of hooks into a bunch of different things. So this is probably going to be the default going forward. We're going to, expect your config to be a JavaScript or a TypeScript file. And we'll still support the JSON for backwards compatibility. But it's going to enable a few interesting things. So if you go here, so yeah, we, load all this, and this is going to require reading from our file system, seeing if you have your personal stage set up, if you haven't passed in a stage. And if you follow the stage context, it's context all the way down. So it's personal stage context, and we read from the little stage variable that we ask you to set initially. If it's not there, we'll prompt you to specify a personal stage. Feel for nothing too crazy here. The other thing that is interesting is we're likely going to move away from the main field. So before, actually, we'll probably still support it if you're passing it in as JSON. But because this is JavaScript, we now can let you just specify your entry point in your config file. So instead of having stacks/index, just in your config file, you can just boot up all your stacks, your app defaults, everything. You can even set up your stacks in the same file if you want to. If it's just like a quick little front end you're deploying, maybe you don't want like a full-blown SST setup or you have a separate stacks folder. Because the config is a JavaScript file, you can define your stacks in there if you want to. Of course, for real projects, defining all that in a single file is not going to be organized, so you probably still would break it up into a separate stacks folder. But this provides some flexibility with what you can do there. So that's the config. Okay, so if we keep following this, we can call stacks.build first. I think because I was timing something. Let me see what's under here. Okay, so there's more context usage here. So once we hit stacks.build, a project root use, it just gets us a root project. Use state, which gets us just some pulls us stuff from the local file system. The use config you saw was there as well. I don't remember where exactly I use this, but I want to also show the credentials stuff. Another thing that I rewrote is how we load credentials. Under certain scenarios, especially if you're using SSO, the previous CLI loading credentials was pretty slow. But we have, again, using this context memo thing where we will really efficiently load the AWS configuration and reuse it wherever it's needed. And we even take this a step further where we do. So if we look at let me see if it's in secrets. Yeah, so we have a nice little use AWS client hook. So if the first time when CLI is booted up, if it hits this line of code, use a SSM client, it'll initialize it, do everything as usual, but it'll save it into a cache. So any following calls that are using SSM client, it'll reuse from memory. This seems like it's a minor thing, but I measured this, and initializing the AWS client does have some overhead. So reusing existing ones as needed is going to speed things up. So like I mentioned, a lot of these optimizations are really small micro optimizations, like saving 50, 100 milliseconds here and there. But there are just so many of these that we're going to be doing that when you add it up, it's going to be user visible. The idea behind the context is, in the CLI, let me find it again. In the CLI, we preload almost nothing, right? We're really just doing command line parsing and we're immediately triggering the function that needs to run. The nice thing about context is it inverts things. So instead of having to specify everything that update might potentially need up front, as update starts to run, it'll boot up the various contexts it needs. This makes it so every command only loads up in a very granular sense exactly what it needs. It kind of solves a problem in our existing CLI where a bunch of initialization logic runs no matter what command you're running, and it's a little bit hard to optimize that. So it's the same concept in Lambdas, right? When you're running a Lambda, the benefit of context is you don't have to specify everything up top. You can just leave the Lambda pretty dumb, and as it hits code that needs different context, that's when it'll get booted up, and that makes sure that things as little as being loaded in and run as possible. That's kind of why it's been nice to see the context stuff scale to the situation. All right, so the next thing is AWS IoT. So this is something super weird that I'm really excited about because it's having a lot of performance benefits. So right now, if you're using SST, when you run SST start, it deploys a debug stack, which you've probably all seen. In the debug stack, there is a WebSocket server and a Dynamo table, if I remember correctly. The reason we deploy this is when SST start runs, it connects to the WebSocket server, and then it saves like a connection ID in Dynamo. Then when a function invocation shows up, look up in Dynamo which connection to forward to, and we send message to the WebSocket server, which then comes all the way down to your local machine. It gets processed, the function runs, gets forwarded back up. And this is pretty fast. I don't, like I'm sure people notice some lag, but I don't think anyone's like specifically complaining about the speed. But it is, you know, kind of annoying that we have to deploy like, this infrastructure to do this. Like I said, there is overhead with the WebSocket server itself. It's not super fast. I found that AWS's API Gateway's WebSocket stuff is pretty good, but it's not like the fastest thing ever. And you definitely notice in local development that there's like a little bit of a delay, that like a user visible delay that you can see when you're invoking functions. We built a new prototype that works completely differently. So this isn't something a lot of people know about, but every AWS account, as soon as you sign up for the account, as soon as you create the account, it comes with a built-in IoT endpoint. It's part of AWS IoT. Sorry, it's an MQTT endpoint. As part of AWS IoT, and I think the way you use it is it's basically a pub sub system similar to like EventBridge, but meant for connection by like edge devices, right? So like IoT devices or like even people's front ends, and it's a built-in MQTT endpoint that's there and ready to go for your use. You don't have to spin up anything; it's just automatically there. You just have to send AWS an API call to get the endpoint URL. And this can be used for any kind of pub sub communication, and it works over WebSocket. So the new CLI, we can actually skip WebSocket server and Dynamo table entirely. The CLI is going to connect to IoT, and it's going to subscribe to a topic. And the topic is going to be something like SST slash like your app, your stage, something like that. And when a function invocation comes in, it'll publish to IoT. The CLI will receive the message. CLI, once it has a response, it'll publish to IoT, and the function will receive the response. So main benefit is there's no additional infrastructure to deploy. And so SC start will work out of the box pretty quickly, even on your first deploy. And this whole flow is a lot faster. So we did a bunch of benchmarking, and we're seeing the end-to-end latency 3 to 4 times faster. So on my machine, doing like a simple hello world invocation, which basically is like 1 millisecond run on my machine, but the entire flow before was 200 to 300 milliseconds. And now we're seeing it around like sub 50 milliseconds. And it doesn't feel like it's running locally on my machine anymore. It is super fast. So this is something we're really excited about, because not only is it a performance benefit, but it's also just less complicated. The code we have to manage all this is like a third the size of everything else from before. So it was really cool. We had an idea for the prototype a while ago, and I was able to, a few weeks ago, actually get it together. And I have it working in the CLI. It's obviously not fully wired up, but you can see like here I have, when a function invocation comes in, I'm publishing to SST app to this topic with a function ID with a response, and the function that's running in AWS will receive this and forward it. So a lot faster. Pretty excited about this one. All right, the next one, this one's also big. So in our current CLI, there are, I don't even know where exactly it is, but let me see if I can find it. Just give me 1 second. It's definitely in core. It's called helper, CDK helpers, I think. Yeah, here we go. So right now, because SC is built on top of CDK, we need CDK to help us do things like deploy your stacks. There's a bunch of different things that we use CDK for. CDK, unfortunately, is not really designed to be run programmatically. It's purely a CLI tool. The thing that I was showing earlier where we want SST to be able to be called programmatically, CDK has not put in, like, there's just not a feature that they considered at all. So right now, when we call in a CDK, we're doing something kind of like inefficient. Let me see where this is. I gotta find it. We're actually spawning CDK as a separate process, and this requires a ton of hacks for us to get working correctly. And there's just a bunch of overhead, spawning a new process. We also like kill it to like make it stop doing things that when we need it to stop and we take over. It's pretty ugly, and like there is a lot of overhead that comes from this. So every time you run a deploy, um, we need to do this. And I think even when we run a synth, this is part of it. SST core synth. Is this where it is? Okay, I don't know. I don't know where it is, but the idea here is we're spawning CDK and there's a lot of overhead with that. I did some profiling of this, and there's a lot that happens when CDK boots up. It needs to initialize all of CDK, which if you look here, you guys maybe saw me talking about this on Twitter a little bit. See this import AWS CDK lib. This is a gigantic library. Just this import takes several seconds the first time it's run. So if we're spawning CDK every time we want to synthesize, every time we want to deploy, there's like already an overhead from just calling this import thing here. I submitted a PR to try to fix this and make this go a lot faster. Unfortunately, CDK rejected it. So this is not something we can directly fix, but if we can get away from spawning CDK every single time we want to do things, it'll effectively avoid this issue. You're still going to pay the cost when your CLI first boots up, but every like subsequent synth, rebuild, things like that, you won't pay the price there. So the way we're going to be doing this now to avoid spawning CDKs, we are actually going to be able to be calling it programmatically. That's actually what I'm working on right now for this week. I'm trying to get SST deploy working without spawning CDK as a separate process. This is possible. I've gotten a prototype of it working. It requires like deep importing stuff inside CDK. So it's pretty, again, it is kind of messy. It's not like this clean integration between SST and CDK, but it is going to be better than spawning like the CLI every time we need to do something. The challenge here is their functions aren't nicely isolated. So that's like calling like their internal deploy function also triggers a bunch of UI in the CLI to show up. So like untangling that and just pulling in the functionality that we need and doing it that way is gonna take a little bit of effort, but it's gonna be worth it because we're not, spawning CDK every time. There's also a bunch of side effects that happen because of that. We kind of create a temporary file that we feed into CDK. Creating that temporary file has some overhead. So there's just like a bunch of little things that are slower because we need to do this. And like I said, because the focus is on performance, we're going into like every little line and thinking, is this absolutely necessary? How can we avoid doing this? So not spawning CDK is one of those things that create a bunch of benefits downstream. Let me see if I have this implemented to some degree. No, I don't. I think I have it in another branch. Okay, so yeah, I can't really show how we're calling into it, but it is possible, which is the good news. So next thing, event bus. So one of the key insights we had was the CLI needs an internal event bus because there's tons of events that are happening. And in our previous CLI, we didn't really have that. So it was a mess of like callbacks, a lot of things like little piece of functionality needing to know about a bunch of other things, changing something in one place affected things in a bunch of other places. And it's all the same reasons why you use an event bus in the back end. You want to decouple certain parts of your system. And we realized the CLI at its core is just really an event system. It's going to keep track of a bunch of events and trigger things that happen in response to those events. So we already started doing this in the existing CLI, but we fleshed it out a little bit more in this new one. So we have this little like use bus thing, which will give you a way to publish and subscribe to events. So if you look at this IoT example, you can see that, what are we doing here? Yeah, so when we subscribe to IoT and we get a message from IoT, we are just publishing that event to the bus. So this little IoT functionality, it doesn't have to know about anything else about the system. Its only job is to connect to the IoT endpoint, receive the messages, maybe format them a little bit, and then publish them to a central event bus. And then other things can respond, it can subscribe to that and emit different events that get sent through it as well. So in this case, right, this is when a function invocation comes in, and you can see like we are making this all type safe using this. Yeah, let me see. Yeah, this is, yeah. So if we look at, so this little piece of functionality is just subscribing to a function invocation event, which is coming over the AWS IoT, and it's publishing a function responded event to the same event bus. So this will take care of, now this is like a demo here, but this will take care of running your function locally, getting response and forwarding over. What's nice about this bus concept is this is what lets us make SST more extensible. If we have a central event bus that's emitting all of these events for various different things, there's no reason we can't allow plugins to also subscribe to those events. So if you take this specific example for function invocation, we might have built-in handlers to handle certain runtimes, right? Like we support JavaScript, Python, Go, etc. And our internal handler for this event will handle those. If you want to build your own plugin that receives like a Rust invocation and you want to like run some local Rust binary to run and like do your whole thing, you should be able to write a plugin that subscribes to the same event bus and handles different things. Any kind of file event, we're already going to have like an optimized file watcher watching your project. So we'll have events for, hey, this file changed. You can trigger whatever logic you want in reaction to that. So for us, we use that internally to say, okay, whenever any file related to GraphQL changes, let's rerun the GraphQL code gen. But you can hook into the same event system as well. So the goal here is to publish. So you can see here we have like these event types defined. We want to publish a library of all the events that happen in the CLI, and people can subscribe to them and handle them however they want. So this is going to be the core of what allows extensibility. These are all just rough, prototypes, but the final thing will end up looking loosely like this. Cool. What's the next thing I have on my list? All right, SSD update. Oh, hang on, going back a little, I realized another issue with spawning CDK we were talking about earlier is like I said, we like code gen a bunch of these files that get run. That's a root of what breaks compatibility with a lot of modern package managers. So using PNPM and SST has some issues. Once we stop spawning CDK and we just treat it like any other package that we're calling into, that will unlock PNPM support. I actually even want to use PNPM internally for ST's own repo. So again, one of those things that have been asked for a while, like that issue's been there for a while. The reason we haven't fixed it is because there's larger restructuring. We'll kind of implicitly solve some of these things. So we want to support we want to do things in a very standardized way, do nothing weird. That way it should just work with all the other tooling that's out there, and there shouldn't be any surprises. So that brings me to SST update. So this is like a simple little command, but it does come in handy, right? So SST update lets you update, the various packages that exist and make sure that CDK is tracked with them. So the current CLI has SST update in it as well, but one, it's slow because it's also installing the packages for you. Two, it doesn't work well with all package managers because we tried to, detect what package manager you're using and call into it directly. That was a wrong approach. It's really hard to make something that universally uses any package manager. Anytime a new package manager comes out, we need to update it. So we took a stupider approach here, and we just are going to update your package JSON, and you can run your package manager's install command after. The result of that is ST update is now like it runs in like an imperceptible amount of time. Maybe I can actually demo it. Let me see. Yeah, so I think I can demo it here. ST update. Boom, done. So 400 milliseconds, a lot faster than it was before, and it's going to work every time without being buggy at all. So that should make that a lot better. So again, this is the result of like going and looking at every single line and implementing something that runs as fast as possible. The other thing we're also doing as part of all this is I'm using standard libraries as much as possible. I think SST has a lot of dependencies, so installing it can be pretty slow. Additionally, especially with these new alternative JavaScript runtimes coming out, the more we stick to standard Node APIs, the better. With so many people looking into Bun and how much faster it is, we want to make sure that there's no special reason that SST doesn't work with Bun. AWS SDK doesn't work with Bun currently, so that's the actual limiter. But once that's fixed, there shouldn't really be any limitations on our end for why you can't use it. We're going to use standard Node APIs wherever we can. That kind of just allows things to integrate better and be as fast as possible as well. Okay. The next thing, I don't really have something visual to show for this, but this has come up a lot more with the new SST config feature. So right now, if you do the following, if you do SST build and then SST deploy, this actually triggers two separate builds. Like SST build run the build and SST deploy won't use the same output from SST build. It'll run SST deploy separately. So the issue with this is it's just slower in CI and it's really just a speed issue. The question is like, why would you separate these? Why not just run SST deploy? Like why run the two separate commands? There's a few different reasons. Some people have a CI process where they build artifacts and then separately deploy artifacts. So it can be nice to kind of build everything up front automatically and have a human step to, trigger the deploy that reuses the same artifact from SST build. So if you ran like tests against it and did checks against it, the deploy is using like the same artifact. But the more practical thing that has come up is type checking. So SST config generates a bunch of types for your config object. If you do, so the current flow that I've had is type check and SST deploy. The type check is always going to fail because SST hasn't generated the types for config yet. So it'll say that I'm trying to use config values that don't exist. So I've had to update my CI to look like this. I need to build SST first, then do the type check, which makes a lot of sense. But now, running SST deploy, it's going to run the build again. So it's just like a speed thing. So we want to make sure that SST deploy can use the artifacts from SST build. Again, a super old issue that's been there ever since I joined SST. Just something we've never been able to prioritize before. Cool. Let me see what else I have here. Function analyze. So this is again like a little scrap feature I built. So if you watch my function bundles video, I go over a way to analyze your functions to make sure they're not bundling too much. I want to make that a first class feature of SST. So we want to have a function analyze, like SST function analyze feature that builds your functions the exact same way they'd be built for production, and then analyzes like the metadata to say, okay, here's what's causing your function to be so big. Right now, you can do all this just by calling esbuild directly, but it's like a long, annoying command. And we should be able to do a better job because we know exactly what context your function is being built in. So we want to have this analyze command that analyzes it and prints out useful information. So we're not doing much of the hard work here. Like there's already a esbuild analyze metafile concept. The key is making sure this is populated in a way that matches how your function is going to be deployed in production. It would be cool if we got to a place where we're running this automatically on every deploy, so we can print out like warnings of, hey, this file looks really big. Are you sure that you didn't mess up some import somewhere? Things like that. And I think that's everything I had on my list. Oh, there's a bunch of other stuff around the CLI UI. I forgot to write this down. So another thing that has bothered us for a while is the UI for the CLI isn't great. The way it kind of like prints out a bunch of stuff when you're deploying, like it's all interleave, right? You have, especially if you're deploying stacks in parallel, you have some stacks finish and there's like stack finish messages in between other stacks being deployed. We want to build like a much more interactive UI around CLI so that it's not this infinite scrolling thing. When you're doing a deployment, we want to show each stack. We want to show spinners for each stack as it's deploying. So you'll see what's deploying in parallel. Under each stack, we want to show spinners for every resource it's deploying. So you'll be able to see like, okay, all right, my API stack is deploying. Oh, okay, my API is deploying. Oh, okay, my routes are deploying. Okay, route 1 is finished. Route 2 is finished. Route 3 is finished. We want to make this a lot more usable. And we also want to print out the amount of time each resource takes. So we can't do much to make CloudFormation go faster, but we can definitely surface like where CloudFormation is slow. So we can build up knowledge over time around, oh, this type of change, tends to be pretty slow, and you're kind of aware of what to expect as opposed to making a change and kind of being confused with what's going on. Like right now, the CLI output isn't very useful during a deploy. And additionally, like especially if you have requests coming in, things like that, it does get pretty hard to read. So we want to build like a proper CLI UI that, is useful for the situations that come up. And so, yeah, I think that's everything. Let me just take a quick look at what I have so far and see. Oh, yeah, okay. Here's another little thing that it doesn't affect you guys as much, but it does affect us. Exceptions in our current CLI were kind of a little bit of a mess. Like you would sometimes see this confusing stack trace, even if it's a specific error. We're being a lot more intentional with the errors that we're throwing. So we have this concept called a visible error. And visible errors will be very detailed, nicely formatted. For the most part, you should only ever be seeing visible errors. You shouldn't really be seeing like a weird exception that happens, like that's coming from the CLI. If that does happen, we're still going to try to format it correctly and in a way that's unobtrusive. And we like put a link to the Discord, so you can just copy paste there and paste it right away. Because we have this telemetry system, we probably will eventually try to forward these to us automatically. We just need to think about whether that's appropriate or not. But in general, just when things go wrong right now, it just feels like SST exploded. We want to have stuff fail nice and gracefully. So let me see if I have a place where I have this. Yeah, so this is a good example of where, if we can't find an SST config file, like we print out this nice little thing. Let me actually see if I can get this to trigger. Oh no, that's because that's a real project. Yeah, so you see fails, you get this nice readable error. No like stack trace, because stack trace is irrelevant here. We know exactly what went wrong. So just like this on the UI side, I think CLI is you just don't prioritize a UI initially because like the word UI and CLI, just don't put those together in your head. But we've been taking a lot of inspiration from other like really modern tools that ship really like nice looking, useful CLI UIs. We want to make sure ours is competitive with that. Ultimately, we want to make ST feel like a modern tool. I think it right now, functionality wise, it can do a lot of the things that you need SST to do, but it definitely doesn't feel like a modern tool, right? If you're using something like Vite, starts up instantly, everything like just works. There's like a useful output. We're definitely a little behind when it comes to that, but with this effort, we should kind of get it up to speed. Okay. I'm sure the next question I'm going to ask, like, what's the timeline for this? It's going to be interesting because the way we've talked about doing this is I'm actually just going to be committing this stuff to master, and it's going to be consistently getting released. Right now, it's pretty useless, right? You can really only do, I guess, the update. That's the only command that's implemented in its entirety. But we're going to keep, shipping these as is. And at any given time, you can use the new CLI for, like I see, deploy whatever we have done, whatever is working. So you can help us test it out. But this is a big effort. I think in our roadmap, we have it over the next, most of the work's gonna happen over the next month, but there's still gonna be more work that follows after that. And we're shooting for like an official release sometime at the end of November. So that gives us like 2 months or so. September, October, yeah, so 2.5 months or so. So that's what we're aiming for. The features that I share with you, I think, are definitely going to make it in there. There's a bunch of other stuff that we might deprioritize, But the idea here is to give us a really good foundation for everything we do going forward. A lot of these old issues that have maybe blockers for some of you, or not blockers, but just annoying workarounds you've had to do. I think a lot of that stuff will get unlocked with this. So yeah, I'm pretty excited about this. It's going to be like my entire focus for the next couple months or so. And just as a team, we are like the overall goal is to make SST feel extremely modern and make it feel as good as all the other tools that you're used to using. Even though we're building on top of AWS and on top of CDK and CloudFormation, there's like limits, but we think that we can get this feeling like a modern tool. So yeah, all right, that's everything from me. Thanks for joining. Like I said, this is a pretty casual thing. I'm gonna be doing, so once I'm settled in Miami, I'm gonna be doing some more like intensive streams where I'm actually like building more stuff with SST. One of the technologies I've been playing with lately is Replicache, and I think it's really cool for people building client-heavy applications. Most of the work I do is on very client-heavy applications, and Replicache has been really awesome for that. So I want to do like a whole thing on implementing Replicache with SST, and it's probably gonna be my next big stream. I don't think it'll happen next week, but next couple of weeks once I'm settled in, I'll show that off and how cool it is and how like amazing it makes your app feel. All right, that's all for me. Thanks everyone for joining. Have a good